Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss permutations and combinations. Permutations and combinations. In this chapter, we are going to discuss the sums in the exercise 7.3. In the previous class, we have discussed the concepts of this exercise 7.3 and three questions so far we have discussed. Yes or no, my children? I have given fourth question as homework. I hope you have done that question number 4. Yes or no, my children? I hope you have understood the concepts of this exercise 7.3 well. I hope you have learnt the concepts of exercise 7.3 well. Haven't you, my dear children? Right. Now come to this next questions. In the page number 148 in the textbook. Are you ready to listen the class? Right. See the question number 5. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? Understood this point, my children? How many persons are there in a committee? 8. Let us write the given data. Come to the solution part. Number of persons in a committee. Total 8 persons are there. How many positions are there? Chairman and vice chairman. We have to choose a person to these two positions. Okay, my children. So let us take two blanks for chairman and vice chairman. Okay, my children. So therefore, number of ways of choosing a person, choosing a chairman and a vice chairman, assuming whatever the sentence is given in the question, I am writing the same. Assuming one person cannot hold more than one position is equal to this number of ways of choosing a person is equal to number of ways of filling the blanks filling the two blanks for chairman position and for vice chairman position. We are taking two blanks. Okay, my children, two blanks for chairman and vice chairman and vice chairman positions. Okay, my children. So let us assume that this is for chairman position and this is for vice chairman position. It is given that a person cannot hold more than one position, means repetition is not allowed. Okay, my children, one person should have only one position. So this first position, for this first chairman position, how many possibilities are there? Out of 8 persons, we can choose any person 8 ways. Yes or no, my children? Here for the second position, second event, second job, second operation. Here first operation is over. Here first operation is performed. After this first operation is performed, we have to perform the second operation. In how many ways we can perform this second operation? After filling this first position, one person has already selected for chairman position. How many persons will be left in our hand? 7. Yes or no, my children? So by the principle of counting, fundamental principle of counting or fundamental principle of multiplication, 8 into 7, 56. Okay, my children. So first blank, can be filled by 8 ways. Okay, my children. And second blank can be filled by the remaining by the remaining 7 persons in 7 ways. So by the fundamental principle of counting, therefore by in short form we write F dot P dot C. These 3 letters stands for fundamental principle of counting. By the fundamental principle of counting, required number of ways. Required number of ways is equal to, how can you calculate, how can you find the number of ways? 8 into 7, because these are 2 operations, 2 events are there. We have performed the first event in 8 ways. After that one, second job is done in 7 ways. So 8 into 7. Understood this point, my children? That is 56 ways. Understood this point, my children? Right. Now come to the next question, that is question number 6. Find n if n minus 1 p3 is to n p4 is equal to 1 is to 9. Okay, my children. While you are writing this notation, don't write in the same line n minus 1. Down here as a subscript, write a capital letter P. After that, for this P, write 3 as a subscript. Okay, my children, understood this notation, how to write this notation? Don't write n minus 1, P and 3 in the same line. Don't write like this. Okay, my children, n minus 1, P, 3. Don't write like this. Okay, my children, I'm telling you how to write this notation. Write n minus 1. After that, write here capital letter P as a subscript. Understood this point, my children? For this point, for this letter P, write here 3 as a subscript. As you write x1, y1 like this. These are called subscripts, small letters. Like this you have to write downside. Understood this point, my children? Is this point clear? How to write the notation? Right. Now come to this point. Here we know that NPR is equal to n minus 1 into n minus 2 into n minus 3 into and so on n minus r plus 1. It means if you know the numerical value here, if you know these numerical values, we have to write these factors starting from this number to how many, what is the number 3 here. So we have to write 3 factors starting from this number and in the reverse order, in the descending order. Understood this point, my children? Right. Given n minus 1 P3 is to NP4 is equal to 1 is to 9. This is a given statement. Okay, my children. Let us write this ratio as a fraction. Okay, my children. So, n minus 1 P3 whole divided by NP4 is equal to 1 is to 9. Because A is to B can be written as a fraction like this. A ratio can be written as a fraction, a rational number like this. Understood this point, my children? By using this point, I wrote LHS as well as RHS. Okay, my children? Right. This implies, so here I told you, if the number is given clearly, numerical value, then we have to write the expansion of this notation starting from this number, and we write in the reverse order, in the descending order. So, n minus 1 into n minus 2 into n minus 3. These many factors, how 1, 2, 3, whatever the number is there, that many factors should be right here. So it should be written. Understood this point, my children? Whole divided by, see here, NP4. So we have to start by this number, n. How many factors you should write in the descending order? 4 factors. Here 4 is there. Understood this point, my children? By observing this number, we can come to conclusion that how many factors should be written. So here 4 is there. So we have to write 4 factors. So n into n minus 1 into n minus 2 into n minus 3. How many factors count here? Here n is the first factor, n minus 1 is second factor, n minus 2 is a third factor, and n minus 3 is a fourth factor. Understood this point, my children? 4 factors, 1, 2, 3, 4. In the numerator, 1, 2, 3, we wrote the 3 factors. Understood this expansion, my children? By using this definition, we wrote here. That is equal to 1 by 9. Understood this step, my children? Right. This implies here n minus 1 gets cancelled, n minus 2 gets cancelled, n minus 3 gets cancelled. What do you get in LHS? 1 by n is equal to, in RHS, 1 by 9. Understood this step, my children? Right. This implies n is equal to 9. By cross multiplication, you get n is equal to 9. Understood this point, my children? Right. Now come to the next question, that is question number 7. In this question number 7, there are 2 parts. See this first part, find or if 5PR is equal to 2 into 6PR minus 1. Understood this question, my dear children? Here we have to find the value of R. Okay, my dear children? In the previous question here, numerical values are given. Then we have expanded this NPR easily. Whatever the number is there, that many factors we wrote starting from this number. Yes or no, my dear children? But in this case here, this is not a numerical value. Numerical value is not given in this position, in this place. Here a variable is given, letter R is given. In this case, we use this formula. This is also another formula we have discussed in terms of factorial. NPR is equal to n factorial by n minus r factorial. We use this concept. Okay, my children, to find the value of R. And n factorial is equal to n into n minus 1 factorial. If you want to expand up to some extent, after that immediately we have to write factorial notation. If you don't want the full expansion of n factorial, suppose if you want to three factors, so if we write 3 factors, after 3 factors immediately we write factorial symbol. We don't write, we are not interested to write expansion of this n factorial completely. Actually, what is meant by n factorial? N into n minus 1 into n minus 2 into n minus 3 into so on and so on. 5 into 4 into 3 into 2 into 1 up to 1. Starting from this number to 1, we have to write. Yes or no, my children? But if you don't want to full expansion up to some factors only, after that immediately we have to keep factorial notation. We stop that by factor and immediately we write factorial notation. Understood this point, my children? Right. We use these 2 points to solve the value of or to find the value of r. Okay, my children. Right. What is given here? 5p r is equal to 2 into 6p r minus 1. Okay, my children. Right. This implies, let us use this notation NPR where n is equal to 5. So 5 factorial by 5 factorial by 5 minus r factorial. Understood this LHS, my children? By using this formula, I wrote this LHS part. Okay, my children, right, come to RHS. 2 into, again use the same formula. 6 factorial by 6 minus of r minus 1 factorial. The same formula I am substituting, n is equal to 6, r means r minus 1. Understood this step, my children? Right. This implies 5 factorial by 5 minus r factorial is equal to 2 into, don't write here 2 into 6 is 12 factorial. Don't be mistake. Don't write here like this 2 into 6. Don't multiply directly. Okay, Maricel, this is not a numerical number, numerical value. So you should not multiply 2 into 6, 12 factorial. Okay, Maricel, 6 factorial can be written as 6 into 5 factorial. Yes or no, Maricel? By using this property. I want only 2 factors. So 6 into 5 factorial. Okay, Maricel, right. Whole divided by 6 minus or minus of minus 1 plus 1. Yes or no, my children? In these brackets, we use the distributive property. Minus or minus 1 into or minus or minus 1 into minus 1 plus 1. Understood this step, my children? Right. Here, see, 5 factorial gets cancelled in the numerator. Then what we will get? 1 by 5 minus r factorial. 5 minus r factorial is equal to, now we can multiply because this is not factorial notation. So 2 into 6 we can write 12, we can multiply, this is number, this is also number, then we can multiply. Understood this point, my children? Divided by 6 plus 1, what you get is 7 minus r factorial. Understood this point, my children? Right. This implies 1 by 5 minus r factorial is equal to 12 by, now let us expand by using that property. 7 minus r, we have to reduce 7 minus r minus 1, we have to reduce by 1. So what you get is 6 minus r. Yes or no, my children? So 6 minus r. Again we will reduce 1. We reduce 1 from this number. So 6 minus r minus 1. What do you get? 5 minus r. Yes or no, my children? So 5 minus r. I am stopping this expansion by this factor. Okay, my children. Immediately we have to keep a factorial notation as I have said here. Okay, my children. I have expanded this factorial notation till the 3 factors only. After 3 factors, immediately we have to keep a factorial notation. Understood this point, my children? So here 5 minus r factorial, here 5 minus r factorial gets cancelled. Understood this point, my children? Right. That is equal to 1 is equal to, in LHS what will you get? 1 is equal to 12 by 7 minus r into 6 minus r. Let us multiply these two factors. 7 6 42. 7 into minus r minus 7r, minus r into 6 minus 6r plus r square. Yes or no, my children? Right. This implies 1 is equal to 12 by r square minus 13r plus 42. Yes or no, my children? By simplifying this expression, what you get? R square minus 13r minus 7r minus 6r. What will you get? Minus 13r plus 42. Understood this step, my children? Right. Now cross multiplication. By cross multiplication, we get r square minus 13r plus 42 is equal to 12. Understood this step, my children? Right. Let us transpose this 12 to LHS. Then it becomes minus 12. Yes or no, my children? So r square minus 13r plus 42 minus 12 is equal to 0. Understood this step, my children? We are transposing plus 12 to LHS. Then it becomes minus 12. Understood this point, my children? Right. Now let us simplify. R square minus 13r plus what we will get here, 42 minus 12, 30 is equal to 0. Understood this equation, my children? Right. If you observe this equation, it is a quadratic equation in variable r. Yes or no, my children? This is a quadratic equation in the variable r. Now let us solve this quadratic equation in r. Okay, my children? Right. So in LHS, if you observe, this is a quadratic expression. In LHS, it is a quadratic expression in R. To factorize this quadratic expression, I am using the splitting the middle term method. Do you remember that method, my dear children? Splitting the middle term. What is there here? 13R. We are splitting this middle term by taking the factors. 10 3s are 30. So 10 3, 60, 13. So minus 10R minus 3r plus 30 is equal to 0. I have splitted this middle term as minus 10r minus 3r. If you simplify these two numbers again, we get to minus 13r. Yes or no, my children? Yes. So here from these two terms, r is common factor. So r minus 10. And from these two numbers, minus 3 is common factor. Here also we get r minus 10. This implies again from these two terms, r minus 10 is a common factor. Then we get r minus 3. Understood these steps, my dear children? Right. This implies r minus 10 is equal to 0. R minus 3 is equal to 0. It takes any one of these two values. Okay, my dear children? Right. This implies r is equal to 10. If you are transposing minus 10 to RHS, it becomes 0 plus 10. Means 10 only. This implies here r is equal to 3. If you are transposing, if you are moving minus 3 to RHS, it becomes plus 3. So 0 plus 3, 3 only. Okay, my children, we got here two values for r. But in this question here, 5PR is there. So that number, downside number, subscript should not be greater than the beginning number, first number. So R value should not be taken here as 3 because therefore R is equal to 3 because R is equal to 10. It is greater than 5. Okay, my children, we should not to take R value. R value should be 0 less than or equal to or less than or equal to 5 only. Not more than 5. Understood this step, my children? Right. Here, I am not explaining the second part of the question number 7. Please try the second part of this question number 7 yourself, my children. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my children. Will you try the second part of the question number 7 yourself, my children? Right. Now come to the question number 8. How many words with or without meaning can be formed using all the letters of the word equation? Using each letter exactly once. Okay, my children, understood this question? Right. First of all, come to the solution part. First of all, let us write the letters of the word. Okay, my children. Letters of the word equation. What are the letters of the word? E, Q, U, A, T, I, O, N. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So total number of letters in the word is 8. Number of letters. So total number of letters in the given word is 8. How many letters to be taken here? We had to write the words by using all the letters of the word. We have to use all the letters of this word. By using all the letters of the word, we have to write the words with or without meaning. Okay, my dear children. Number of words, number of letters to be taken. How many letters can be taken at a time? 8 letters. All the letters should be used. Okay, my dear children. Therefore, number of 8-letter words by using all the letters of the word. Equation. So total number of words, total number of letters in our hand is 8. How many letters should be taken at a time? 8. So 8p8. These are the letters in our hand. These are to be the blanks to be filled. 8 blanks. All the letters should be taken. SR number is so 8p8. That is equal to. How can you explain this one? 8 into. We start from this number and we write 8 factors in the descending order. So 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Yes or no, my children? So multiply all these 8 factors. What you get? 40,320. These many 8-letter words can be written. Understood this point, my children? Right. Now come to the next question, that is question number 9. How many words with or without meaning can be made from the letters of the word Monday? Assuming that no letter is repeated. No letter is repeated. If first part 4 letters are used at a time and second part of this question all letters are used at a time and third part of the question all the letters are used but first letter is a vowel. Understood this question, my children? In this question there are 3 parts. Okay, my children, right. Come to the solution part. First of all, write letters of the word Monday. What are the letters of the word Monday? M, O, N, D, A, Y. Yes or no, my children? Right. Total number of letters. Number of letters. Number of letters of the word. How many? 1, 2, 3, 4, 5, 6. How many letters are there in this word Monday? 6 letters are there. Okay, my children. Now come to the first part. What is given here? 4 letters are to be used at a time. 4 letters. 4 letters are used at a time. Means a 4-letter word should be made by assuming that no letter is repeated. Understood this point, my children? Total number of letters are 6. There are 6 objects there in our hand. By this, from these 6 objects, we have to take 4 letters, 4 objects at a time. In how many ways we can take 4 objects at a time? Yes, 6p4. We have to recollect the previous knowledge, permutations of n objects by taking r objects at a time is equal to npr. Yes or no, my children? Recollect that previous knowledge. the definition of permutations. The number of permutations of n distinct objects by taking r objects at a time is equal to npr. Yes or no, my children? So we know that number of permutations of n distinct objects taking r objects at a time is equal to npr. Do you remember this definition, my children? Permutations, number of permutations of n distinct objects taking r objects at a time is equal to, it is denoted by the notation npr. Here n denotes number of objects in our hand. Here this r denotes number of objects to be taken at a time. Okay, my children. Here also, how many letters are there in our hand? 6 letters are there in our hand. How many letters to be taken here? How many letters to be used at a time? 4 letters. Okay, my children. Therefore, required number of 4-letter words. Understood, my children? We are writing 4-letter words by using these 6 letters. We are taking 4 letters at a time. Understood this step, my children? 6p4. Now let us find the value of 6p4. How do you find? Starting with this number, and we write 4 factors. Here 4 is there. So 6 into 5 into 4 into 3. Understood this expansion of 6p4, my children? Here 4 is there. Here 6 is there. We start with this number and we write 4 factors. How many factors should be written? 4 factors starting from this number in the descending order. So 6 into 5 into 4 into 3. Okay, my children, understood this one? So 6 5 is 30, 34 is 120, 123 is. So 364 letter words can be made by using the letters of the word Monday. Understood this point, my children? Right. Now come to the second point. What is the second point? All the letters are to be used. All the letters are to be used at a time. All the letters. How many letters are there in our hand? 6 letters. How many letters to be used? 6 letters. Yes or no, my children? Number of letters. In our hand means the number of letters in the given word Monday. Yes or no, my children? Understood this step? Number of letters to be used. Number of letters to be used at a time. 6 letters, all the letters. Yes or no, my children? All the letters to be used. So there are 6 objects in our hand. We have to take all the 6 objects at a time. In how many ways? 6p6, by using this same concept. Okay, my children. Therefore, required number of 6-letter words. Number of 6-letter words is equal to 6p6. How do you find? 6 into 5 into 4 into 3 into 2 into 1. 6 5 is 30, 34 is 120, 120 into 6, 720. Understood this step, my children? Right. Now come to the third part of this question. all the letters to be used, but first letter is a vowel. Understood this third part, my dear children? Here also we have to use all the letters of the word. 6 letters should be used, but the condition is first letter is a vowel. Okay, my dear children? Same as that of writing even numbers. We have concentrated on units place. Yes or no, my dear children? Right. Here also 6 letters are there. First we write vowels. Vowels in the word. What are the vowels in the word? You should have an idea about vowels in English of alphabet. Do you have an idea about vowels in English alphabet? A, E, I, O, U. Do you remember this point, my children? Right. So, what are the vowels in this word Monday? A and O. Only these two letters are there in this word. Okay, my children. So, first we had to fill the first blank by any one of these two letters. Yes or no, my children? Because the first letter should be vowel. Yes or no, my children? So, number of ways, number of words in which the first letter is a vowel is equal to number of ways of filling the 6 blanks as given below, so that the first letter is a vowel. Okay, my children. That is equal to, let us take 6 blanks. 1, 2, 3, 4, 5, 6. Okay, my children. We first focus on the first blank here. In how many ways this first blank can be filled? Either by this letter A or by this letter 2. How many possibilities are there? 2 possibilities. Okay, my children. So the first blank can be filled by any one of the vowels A, comma O in 2 ways. Yes or no, my children? In 2 ways we can fill the first blank. Then after filling the first blank, how many letters will be there in our hand? 5 letters. Yes or no, my children? After filling this first blank, we have 5 letters in our hand. How many blanks are there? 5 blanks are there. The remaining 5 blanks can be filled by the remaining 5 letters. The remaining 5 letters, 5 blanks can be filled by the remaining 5 letters in 5P5. Yes or no, my children? 5 objects are there in our hand. 5 letters are there. After filling the first blank by 1 letter, 5 letters should be there in our hand. We have to fill these 5 blanks. We have to take all the 5 letters at a time. So 5P5. Understood this step, my children? Therefore, by FPC, fundamental principle of counting, the required 6-letter word, is equal to 2 into 5p5, 2 into 5p5, because these are the two operations. The first operation is performed by filling that first blank by any one of these two ways. After that, second operation is filling all these remaining blanks, taking all 5 blanks at a time. Okay, that is 5 ways. Understood this step, my children? Right. That is equal to, let us expand this one. That is equal to 2 into, how can you expand this one? We're starting with 5. 5 into, how many factors should be written? 5 factors starting from this number in the descending order. 3 into 2 into 1. Understood this step, my children? Right. Find the value. 2 5 is 10. 10 4 is 40. 43 is 120. 122 is... So, 246 letter words can be made by using the letters of the word Monday, so that the first letter is a vowel. Understood, my dear children? Right. Now come to this question number 10. Question number 10. In how many ways of the distinct permutations of the letters in Mississippi do the 4 I's not come together? Okay, my children, understood this question? This is a given word, Mississippi. Then we have to find the number of words in which 4 I's do not come together. Okay, my children. And if you observe here, in this word, identical letters are there, identical objects. Some letters are alike, some letters are of same kind. Yes or no, my dear children? Right. First, come to the solution part. Let us write the letters of the word, letters of the given word. Letters of the given word. Mississippi. What are the letters? M, I, S, S, I, S, S, I, P, P, I. These are the letters of the given word Mississippi. How many letters are there in this word? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total number of letters. Number of letters in the given word. How many letters are there in this given word? 11 letters. Out of which, see there, M is only one letter. Only one M letter, one time. M, the letter M is only one time. Identical. I's. How many I's are there? 1, 2, 3, 4. 4 I's. 4 times. This I is 4 times. Identical objects are 4 objects are there. Next, S. How many S? 1, 2, 3, 4. These are 4 times. Next, P. Letter P. So total 11 letters. Yes or no, my children? So 4 identical I's are there, 4 identical S letters S are there, 2 identical P's are there. But we have to find the number of permutations in which 4 I's not come together. Okay, my children. First, let us find the number of permutations of the letter word. If you take all the letters at a time. Okay, my children. Number of 11 letter words. We are taking all the letters at a time. Number of 11 letter word. By taking all the letters of the given word. do you find number of permutations in which n objects are there? Out of these n objects, p letters are alike, q letters are alike, and r letters are alike. Then how do you find 11 factorial? Total 11 factorial by 4 factorial into 4 factorial into 2 factorial. 4 factorial into 4 factorial into 2 factorial. Understood this step, my children? Total 11 letters are there. So we wrote number of letters in the word 11 factorial by 4 identical letters are there, i's. So 4 factorial into 4 identical s letters are there. So 4 factorial. 2 identical p letters are there. So 2 factorial. Understood this statement, children? So this is the number of permutations or number of 11 letter words by taking all the letters of the word. Now let us simplify this number. If you simplify this number, what will get? 34,650. Simplify as a single number. Do you know 11 factorial means 11 into 10 into 9 into like that up to 1. 4 factorial into 4 into 3 into 2 into 1. Similarly 4 factorial. Right. So then we get this number as a single number 34,640. But this is not asked here. We should find the number of words in which 4 i's do not come together. Astronomy children, 4 i's do not come together. So let us assume that 4 i's as 1 unit. Let us 4 i's as 1 unit. As let us use as a star. 4 i's take as a star or some letter Z as Z. For example, letter Z. Okay, my children. Then again write the letters of this word. M. Or four letters. All 4 letters are taken. 4 i's are taken as Z. Okay, my children. M. S. 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 P. P. As are my children. Then this word becomes like this. 4 i's are taken as 1 unit as Z. So in the place of 4 i's, I have taken as Z as 1 letter. M, only 1 M is there. 4 S's, I wrote 4 S and 2 P's. Understood this statement, children? Now in this sentence, how many letters are there? Number of letters. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. As our number children, 8 letters are there. We are assuming that this is as 1 unit, as 1 letter in our mind. Okay, my children. Out of these 8 letters, again 4 S are there. S 4 times and P is 2 times. Understood this step, my children? So by using these letters, let us find the number of 8 letter words. We are assuming that this is as 1 letter. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, my children. So number of 8 letter words. Number of 8 letter words. Total 8 letters are there. As our number children. So 8 factorial by 2 4 factorial, 4 factorial into 2 factorial. 4 factorial by 8 factorial by 4 factorial into 2 factorial. Yes or no, my children? Right. Now simplify this number. Then we get to as 420. If you simplify that number, then you get 840. 840. I simplified that number in the rough work. I got that number is 840. Okay, my children. Do you simplify this number? Yes. Therefore, required required number of arrangements is equal to total number of arrangements with any restriction, without any restriction minus the number of arrangements in which 4 i's come together. Okay, my children, understood this step. Therefore, required number of arrangements is equal to total number of arrangements minus the number of arrangements in which 4 i's come together. What is the total number of arrangements? We got 34,650 minus number of arrangements in which 4 i's come together. What you got here? 840. Okay, my children, we are using the previous results here. 34,650 minus 840. What will you get? 33,810. So, this is a required number of words in which 4 i's do not come together. Understood, my children? Right. Now, I am not explaining the question number 11 in this exercise. Please try the question number 11 yourself, my children. If you have any doubts, ask your doubts and get your doubts clarified. In the next class, I will explain the concepts of exercise 10.4. Okay, my children? Right.